this video, I would like to focus on key principles of modern data visualization platforms which we use to develop digital Q.Sensor. I am going to explain what we think is important for the platform and makes it stand out in this market. The first principle I'd like to talk about is simple implementation and quick go live. To support this principle, our platform is fully built on microservices. It uses containerization and supports popular databases. Definitely, this facilitates the implementation. The use of DevOps, in its turn, saves us from troubles with application servers, while containerization simplifies the implementation and significantly speeds it up. The next principle is easy training and onboarding. We do not use any proprietary technologies or programming languages and provide a lot of documentation and various examples of visualizations to support the user. The solution provides a wide range of preset visualizations, each of them containing demo data, which is especially convenient for beginners. When new users select a specific type of visualization to create a dashboard from the scratch, they get a ready graph at once. Even psychologically, it is much more comfortable if we see how the selected graph works and if it contains some sample data already at the start. The next principle I'd like to make a special focus on is the solution performance and its ability to support high speed of processing and large amounts of data. Firstly, it is important to highlight that it is the database that supports the main workload. Nevertheless, our digital Q.Sensor helps the database. It automatically analyzes the most popular use cases, detects which information and data combinations users request most often, and automatically caches such cases for their immediate delivery to the user. Here we can use a separate database. In addition, digital Q.Sensor automatically analyzes the quality of dashboards, how effectively they process data, and uses special icons to highlight graphs whose generation takes too long or returns too much information to the client, megabytes or more. This approach helps the user to detect these troubles. Another principle of our platform is the use of adaptive design. We continuously develop this feature, and the platform supports special functionality to ensure correct presentation of information on mobile screens, tablets, etc. This feature is highly important for modern visual analytics platforms. Let me switch to the UI and UX and explain how we enable interactivity in dashboards. Speaking of the UX, we have almost 400 types of visualizations, including Sankey, Gantt, geodiagrams, heat maps, and many others. Significantly, we do not have to use ready visualizations as is. We can create custom visualizations by combining separate visual elements. We provide a range of preset examples with demo data and also can integrate with external open source libraries of visualizations upon request. We use several libraries and continuously expand this list. As for the interactivity, we use filters and can flexibly set up how they will interact with each other and influence separate graphs of the same dashboard. Such filters can be used to manage either the whole dashboard or its separate parts. Digital Q.Sensor allows connecting widgets and lookups, which are built immediately into the platform. We support drill down to any depth of detail. A user can click on a graph and drill down deeper and deeper to the more detailed information. During this process, the visualization format can change, for example from a chart to a table, and other underlying layers can also change infinitely. We support various static elements, features, markdown, tables with formatting, including the ones with pictograms. Moreover, we provide a unique element reel summary tables comparable with Excel spreadsheets. These summary tables can process up to 1 million records, which is quite an achievement for the browser. In this part, let me talk about how we process data and achieve high system performance. To process data, digital Q.Sensor uses a no-code designer of requests to data. We design a sequence of requests, and a data graph can be a result of multiple requests, processed simultaneously or consequently with transformations. We support post-processing of data with scripts, such as Groovy, JavaScript, Python, and work with about 30 popular databases, including Microsoft, Oracle, Postgre, etc. We work with web services and use REST and SOAP requests as additional sources, which allows us to collect data not only from databases but also from web services and combine them. We work with Excel-like formulae and can add our own formulae and functions. Their logic is described with JavaScript, which can be done without involvement of the vendor. Upon request, we also provide connectors to popular systems where data appear. Let me tell you a couple of words about system performance. The dashboards that we create actually represent independent microservice-based applications. Several dashboards can be grouped together, packed into a separate microservice and published as an independent PBC, or a packaged business capability. Digital Q.Sensor provides all necessary infrastructure for this. It contains the Publish button, which initiates automatic packaging of dashboards and basis images of digital Q.Sensor in the DevOps pipeline and their delivery to the specified destination. For example, it can be the pre-production environment, where the customer can make final testing before go live. The system also supports self-diagnostics and automatic analysis of the quality of charts. It also warms up cache based on ETL events to ensure quick response to user requests. Now let us talk about the delivery to the user. Firstly, we can restrict user access to the system either by role or by attribute. We provide a request template engine that is used to implement filtering by attribute and allows adding predefined system variables related to user roles or permissions. This is done without coding, only through settings. We also support the Active Directory and other access management systems based on Keycloak. Speaking of the delivery, since we deal with a web application, we store all user filters in URLs and these URLs can be shared. We can integrate charts into other systems as widgets. In case of legacy systems, this can be done via iframe. The user can export images as PDF, raster or vector files. We can set up automatic refreshing of graphs. In this case, the graph can be demonstrated on a large screen, and the user won't have to press F5 to regenerate the graph when new data appear. Significantly, Digital Q.Sensor is built on the event-driven architecture, which consists of loosely coupled microservices, each having a well-defined business capability. This architectural approach guarantees the ability to quickly implement changes and support adaptive scalability of the ready solution. The platform is compatible with all popular databases, and uses the most advanced technologies, including Java, Spring, Spring Boot, Angular. Due to its architecture, Digital Q.Sensor can be used to solve a broad range of tasks across different industries. Let me demonstrate you a vivid example of the use of Digital Q.Sensor. Here, you can see two real analytical dashboards. These are not pictures. In both graphs, we can easily identify a deviation. It is highlighted in red. In these graphs, red means delays, and the graphs clearly point them out. It is especially obvious in the graph on the left, which demonstrates the situation immediately after the implementation of the system. In the right graph, we see that the red zone significantly decreased. This shows that at some moment, people changed the way they work. They realized that they are accountable for this red area and will have to face the consequences. Digital Q.Sensor makes people understand that the assessment of their work becomes unavoidable. This influences their mindset and changes the way they work. People realize that someone will inevitably notice this deviation in the graph. This also gives the user a clear understanding of the overall situation. At any moment, users can check how they cope with their tasks, estimate whether they perform well and do their job right, simply by opening the respective dashboard. This clear vision and the feeling of inevitability of control are extremely important for implementation of changes in the company. In conclusion, I would like to emphasize that we can and should visualize data from information systems. To achieve this, we do not need to embark on complex large-scale projects. Visualizations can be implemented within a week, without any super teams. All we need is some committed business customers and several IT specialists, who understand SQL and maybe JavaScript. We can move iteratively, that it get the first valuable business results in several days or weeks, and come to complex visualizations and methodologies later on, without any losses or decrease in performance. Speaking of the business value, I would like to highlight that, judging from our experience, the solution influences the users responsible for execution of tasks, makes the assessment of their work inevitable, and this changes the mindset and attitude of both the responsible employees and the managers. This approach makes it easier to monitor the quality of work. One more feature of the solution is that all visualizations, built on Digital Q.Sensor, can be integrated into external systems and be used as command elements there. For example, a chart, created in Digital Q.Sensor, can be integrated into a CRM system. After this, the user can click on this chart and manage some processes in the CRM system. To recap, I'd like to underline that Digital Q.Sensor covers the broadest range of various use cases and tasks, regardless of the company industry or business features. It is a cross-industry product, based on the most advanced data visualization principles, which can be used to solve multiple user and managerial tasks, related to visual analysis of business data. To learn more about Digital Q.Sensor, please visit the product website at www.diasoft.com/sensor.